El Niño is a natural phenomenon that occurs when the surface waters of the central and eastern tropical Pacific Ocean become unusually warm. This warming affects the atmospheric circulation and rainfall patterns around the world, especially near the equator. El Niño is part of a larger cycle called the El Niño-Southern Oscillation, ENSO, which also includes La Niña, the opposite phase of El Niño. La Niña is when the surface waters of the central and eastern tropical Pacific Ocean become unusually cool. The normal conditions in the tropical Pacific Ocean are characterized by strong trade winds that blow from east to west, pushing warm water toward the western Pacific. This creates a temperature gradient across the ocean, with warmer water in the west and cooler water in the east. The cooler water in the east is rich in nutrients, which support a high productivity of marine life. The warmer water in the west drives deep atmospheric convection, which forms clouds and storms. El Niño conditions develop when the trade winds weaken or reverse direction, allowing the warm water to spread eastward across the ocean. This reduces the temperature gradient and disrupts the normal patterns of ocean currents and winds. The warmer water in the east suppresses the upwelling of cold, nutrient-rich water along the coast of South America, which affects the marine ecosystems and fisheries. The warmer water in the east also alters the atmospheric convection, which shifts the clouds and storms toward the central and eastern Pacific. El Niño events vary in strength and duration, but they typically last for 9 to 12 months and peak during the northern hemisphere winter. El Niño events occur irregularly, with an average frequency of once every 2 to 7 years. Scientists use various indicators to monitor and predict El Niño events, such as sea surface temperatures, sea level pressure, wind speed and direction, and rainfall anomalies. El Niño has significant impacts on the global climate, as it changes the distribution of heat and moisture in the atmosphere. Some of the common effects of El Niño are increased rainfall and flooding in the eastern Pacific regions, such as Peru, Ecuador, Colombia, Central America, and southern United States. Drought and wildfires in the western Pacific regions, such as Indonesia, Australia, Philippines, and northern Brazil. Reduced frequency and intensity of tropical cyclones in the Atlantic Ocean and increased frequency and intensity of tropical cyclones in the eastern Pacific Ocean. Warmer than average temperatures in North America and Eurasia during winter and cooler than average temperatures in Southeast Asia and Africa during summer. Changes in the migration and breeding patterns of some animals, such as birds, fish, and marine mammals. El Niño also has socio-economic effects for humanity and nature, as it affects food security, water availability, health, energy demand, transportation, tourism, and natural disasters. El Niño can cause crop failures, famine, disease outbreaks, power shortages, infrastructure damage, displacement of people, and loss of biodiversity. El Niño is a natural phenomenon that affects the weather and climate around the world. But how can we predict and monitor its occurrence and evolution? Scientists use a variety of methods and tools to forecast the onset, intensity, and duration of El Niño events, such as satellite observations, ocean buoys, climate models, and indices. One of the main indicators of El Niño is the sea surface temperature, SST, in the tropical Pacific Ocean. When the SST rises above a certain threshold for a sustained period of time, it signals the presence of El Niño. Satellites are able to measure the SST from space using infrared or microwave sensors. They can also measure other variables that are related to El Niño, such as sea surface height, wind speed and direction, cloud cover, and precipitation. Another way to monitor the ocean conditions is by using ocean buoys that are deployed across the tropical Pacific. These buoys measure the temperature, salinity, and currents at different depths of the ocean. They also measure the atmospheric pressure, humidity, and wind at the surface. The data from these buoys are transmitted to shore via satellites in real time. The most well-known network of ocean buoys is the Tropical Atmosphere Ocean (TAO) Array, which consists of about 70 moorings along the equator and off the coast of South America. Climate models are mathematical representations of the physical processes that govern the ocean and atmosphere. They can simulate how these processes interact and influence each other under different scenarios. Scientists use climate models to test their hypotheses about El Niño and to make predictions based on the current observations and historical data. Modern climate models can predict El Niño up to a year in advance, but they still have uncertainties and limitations. Indices are numerical values that summarize the state of the ocean and atmosphere in a simple way. They are often based on the anomalies or deviations from the normal conditions of certain variables, such as SST, sea level pressure, or wind. For example, one of the most commonly used indices for El Niño is the Oceanic Niño Index, ONI, which is based on the SST anomaly in a specific region of the Central Eastern Tropical Pacific. When the ONI exceeds 0.5 degrees Celsius for at least 5 consecutive months, it indicates an El Niño event. By using these methods and tools, scientists can track the patterns that lead up to El Niño and assess its impacts on different regions and sectors. However, predicting and monitoring El Niño is not an easy task, as each event is unique and influenced by other factors, such as climate change. Therefore, scientists need to constantly update their data and models to improve their understanding and forecasting of this complex phenomenon.